Hello, I'd like to prove this trigonometric identity today. That is cosine of theta times cotangent of theta divided by 1 minus sine of theta. This entire quantity minus 1 is identical to the cosequent of theta. Remember, when we do a proof, we only work on one side or the other independently. We don't work on them as if they were an equation. So some of the basics we need to remember before we start: Pythagorean theorem, sine squared plus cosine squared of theta equals 1. If then we take away from both sides, in this case what we're going to do, we subtract from both sides sine squared of theta. If we do that, we get cosine squared of theta is 1 minus sine squared of theta. Okay? Same thing as this. Now remember from first year algebra, and that might be a long time ago, 1 minus x squared is 1 plus x times 1 minus x. And I'm going to apply this to this function right here. So my x in this case is sine theta. I've got a 1 plus sine theta and a 1 minus sine theta. And that's how 1 minus sine squared theta resolves into a factor. Also remember, by definition, the cotangent is equal to the cosine divided by the sine. Cotangent of theta is the cotangent, is the cosine by the sine. Okay, so we're asked to prove this thing here, and what I'm going to do in my approach, there are other approaches on the internet, and some of them are good and some of them are less good. But my approach will be just to work on this term here, and then at the end combine it with the minus 1. So what I want to do is I want to look at just at this first term. Now I've got a cosine times the cotangent. Remember that cotangent, as we said earlier, is cosine divided by sine. So I'm going to substitute this into here. When I get that, I get cosine of theta times cosine of theta divided by sine of theta. And that gives me cosine squared of theta over sine of theta. Then the whole thing is still divided by this 1 minus sine of theta. And that should look a little familiar because that's one of the factors that we produced earlier. And that's where we're really going. So I have cosine squared of theta over sine of theta divided by 1 minus sine of theta. That's equivalent to writing cosine squared of theta over sine of theta over 1 minus sine of theta divided by 1. 1 divided by anything is the same thing. And the reason I'm doing this is to set it up for back to algebra 1. To divide one fraction by another, I want to make these fractions look like they're fractions. You multiply the numerator, the fraction that's the numerator, by the reciprocal, or some call it the inverse, of the denominator fraction. So I have a over b divided by c over d. This simplifies to a over b times d over c. So if we apply this, I know this is getting a little complex, if we apply this to our problem, it really simplifies it a lot. And I've got this top term, which is right here. I take the inverse of this other term, I multiply them, and this is what I get. Oh my goodness, what am I going to do? Well, remember, the key to remember is this guy here. And also then, once you have this guy, it's 1 plus and 1 minus, which is that. So I'm going to substitute in for this cosine this factor. When I do that, I get this thing here, which looks complicated, but when you look at it, you can see immediately this term and this term can cancel. And when I do that, I get 1 plus sine theta over sine theta. That's what you're seeing here. and 1 over sine theta, that will also reduce to 1 over sine theta plus sine theta over sine theta. That reduces to cosecant of theta plus 1. When I go back to the original problem I needed to solve, I can substitute the red equation into this thing. And when I do that, I have cosecant of theta plus 1 minus the 1 that was there. And of course, if I add 1 and minus 1, I get cosecant of theta. So that's what we were to prove, QED. Thank you very much. I hope this helps. It's an interesting little problem. As I said, I like to work on just one term at a time. If you work on more terms sometimes on one side of the equation, you can make the problem more complex than it originally started out to be. Hope I didn't do that for you. Thanks very much.